Okay, Unit 10-4, daily work. Now, what I'm going to do is just kind of get you started on all of these and not really do every little piece of every single one. There's 2 rounds of them, but you just need the experience. And if you go back and look at the examples, it's exactly the same situation. Okay? So, we know that each interior angle of a regular triangle is 60 because if it's regular, it's both equal angular and equilateral. We know that if it's a regular quadrilateral, then it's a square, and each angle of a square is 90. So we found those without using the n minus 2 times 180 divided by n formula. On the hexagon, it wasn't a different type of memory work like that. So we have to take the number of sides 6 minus 2 times 180 divided by the number of sides 6, and that'll give us each interior angle. To find the central angle, you're going to go 360 degrees divided by the number of sides. A triangle has 3 sides, so 360 divided by 3 will give you that. We don't really need that on a square because we know that these are pieces of the diagonals, and the diagonals of a square are perpendicular because the square is a rhombus. So the central angle there is 90 because we know the diagonals are perpendicular, and we didn't even need the 360 divided by n. On a hexagon, this actually comes out to be 120 degrees. Angle 1 is half of that 60, so we get a 30, 60, 90 triangle, and we're going to use 30, 60, 90 triangle rules. On the pentagon, you didn't end up with special triangle stuff. You're going to end up with an interior angle of 108, and so angle 1 is going to be 54 degrees when you're done, and you'll have to use a trigonometric ratio to find FE and some of the other stuff. Okay? And we're going to let you go through those things and practice those. Let's look at number 5. How much larger is the area of a regular octagon circumscribed about a circle with radius 8 than a regular octagon inscribed in the same circle? Hint, use theorems 5, 8, 5, 9. Now, if a regular octagon is inscribed in a circle, then each side of the regular octagon each vertex, of the regular octagon is a point on the circle. And so we would have a situation like this where you would find the apothem and perimeter and find the area. But if we had the regular polygon circumscribed, it means that the sides are tangents. I didn't draw that very good. I better draw again. And so we have a little bit different scenario. Now, this is an odd answer solution, and so I'm going to take you to the odd answers. Let me pause and get you there. So here we are at the odd answer solutions. The circumscribed side would be a tangent to the circle. the inscribed side would have its vertices on the circle. And so this is the work for the circumscribed one. And this is the work for the inscribed one. And if you want to find the difference between them, you subtract. Okay? I'm going to pause again and take you back. You can pause and stay there as long as you want to and study that. Okay, so you have a lot of this regular polygon stuff to study. I did one of each kind. I'm just going to let you go back and watch those examples and run these drills because there's only 2 of each, and I need you to be able to practice doing these things. So we're going to leave it with you. Check the odd answers for the ones that you might need help with. Watch the video, and you should be fine.